Hey guys, Mr. Decker here. This is lesson 22, complex sprite movement. We're looking at computer science discoveries, and we have moved right along. We are in the video games part of the animation and games unit. And let's go ahead and jump in, shall we? We're on bubble 1. This looks like a prediction bubble. It says velocity and the counter pattern. Using the counter pattern with a sprite's x and y property makes a sprite move smoothly across the screen. In this program, the counter pattern is being used with the velocity x property instead. Predict. It says, what do you think will happen when the code is run? Why? All right, so let's take a look at the code. On line 1, variable sprite1 gets create sprite at 50x 200y. So that's going to be down here roundabouts. So there's going to be a sprite appear right here. And then that sprite inside the draw loop is being updated. Let's see. Sprite 1's velocity x gets sprite 1's velocity x plus 0.1. And the background is going to be drawn white over and over again as well. Remembering that the draw loop repeats 30 times a second. So whatever is here is going to move to the right, and whatever is moving to the right is going to increase its velocity. So it's going to start out slower, and then as it makes it to the right side of the screen, it's going to go faster and faster. So the sprite on the left will move to the right of the display, and as it does, it will gradually increase in speed. All right, let's run it. And yes, that's exactly what it did. Reset run. So it starts out really slow, and then it gradually increases in speed. And that's because we're adding to its velocity x. So let's finish there and continue. We're on bubble 2. On bubble 2, velocity in the counter pattern again. This program already makes a car move across the screen. Let's test that. All right, but very slowly. But it's going very slow. By using the velocity x property with the counter pattern, you can change the sprite's speed during the program. Do this. It says add code to make the car speed up. So we're going to go velocity x. I'm going to put that right here on line 9. It's matching it to the car variable that was created on line 1. So the computer knows what we're updating. And then we're going to grab a velocity x block and put that out here. Oh, wait, but before we do that, I need to go to math, and we're adding to its velocity. Now I'll grab this velocity x block, match the variable label. We'll increase the speed by 0.01, reset run, and then it's getting faster and faster and faster at a very slow rate, right? So if you wanted to speed that action up, you can increase that value. And then there, he's speeding up more. Let's try 0.5, see what that looks like. There you go. Now we're cooking with peanut oil, right? So let's try 0.2. I like that. You can still see that it starts out very slow and increases as it moves to the right. I like that value in there. All right. And if we used a bigger number, like say 1, for instance, or 2, reset run, shoom, right? It speeds up really fast and zooms off. I think 0.3 might have a nice effect to it. Yep. All right. So we will finish there and continue. We are on bubble 3. And on bubble 3, falling rock. In this program, the rock should speed up as it falls down the screen. Do this. Add code to make the rock speed up as it falls. So right now it's falling really slowly. So we're going to go with velocity y this time because we're moving down. And this is called rock. And you go to the math drawer. We're going to be adding to y to make it go down. Back to the sprites drawer, velocity y again, rock velocity y again, and then we'll give this a 0.8 maybe. Reset run. Nice. Yep, that looks good. But you know what? I want to make it rotate. So I'm going to give that rock a rotation speed of, let's say, 8. Run. Now our rock is tumbling as it falls, right? I like that effect. All right. If you wanted to mess around with that value, you can. Let's look at bubble 4 together. Slowing things down. This car is going to run into the water. Oh no! You'll need to use the counter pattern to slow it down. So run, the car goes right into the ocean, right off the beach. Okay. So we want it to stop before it gets to the water. We're going to slow that car down before it goes in the water, off the beach. So we'll use velocity X. And we're matching car up here. Math, we're going to subtract because it's already moving to the right. So we want to subtract to make it slow down. Back to sprites, velocity X again, car velocity X again, minus, let's see, let's just put 1 there and see what happens. Oh, 1 is way too big of a number. He's like, nope, I'm on the beach. I better get out of here. All right, let's try 0.4 and see what that does. Still too big. I want to get him as close to the water as I can. Let's try 0.2. That's too slow. 2.5. Pretty good. Let's try 22. 0.22. Ooh, that's perfect. Look at that. He stops right before he gets to the edge, just leaving a little bit of a gap there. That's really nice. So 0.22, that's perfect. Let's finish there. Or wait, what does it say? Can you figure out how to use a conditional above with the above counter pattern to get the car to completely stop before the water? Completely stop before the water. Let's see. So with a counter pattern, getting it to stop. So if we go to control, if drawer, or control drawer, I mean, let's see, and getting this thing to stop. So if we have this here, then I need some math. We'll say if car velocity x equals 0, then car velocity x is 0. So let's try that. Run. Let's try a different math operator, perhaps. Let's see. Challenge, can you figure out how to use a conditional with the above counter pattern to get the car to completely stop before the water? Let's see. Use the counter pattern with a velocity x block that will decrease by 0.25 as it moves across the screen. So maybe I need to change it to 0.25. And then discuss with your partner what do you think will happen when the car finally stops. But we run it, and we've got an error because we don't have anything in. We don't have a boolean inside our if statement. Let's see. Oh, we don't have a sprite.x greater than or equal to. I'm really thinking I'll be back. All right, I have figured it out. So I just needed to think about it for a minute. We do need a Boolean expression here, and we'll use greater than. We'll grab. Hang on just a second. Someone's knocking at my. All right, back at it here. Sprites. If sprite velocity x, if car velocity x is greater than 0, then we will run this part of the code. Once it is no longer greater than 0, this should not run anymore, which means that the car should stop before it gets to the water and just stop. All right, that works. And then I still like 0.22 better because it stops just there. Oh, but look at that. It's floating backwards. Weird. So I'll use 0.25 because that does work better ultimately because the car is not floating backwards now. All right, finish and continue. All right, let's work on this rising bubble. We're on bubble 5A. And on bubble 5A, this program makes a bubble rise up. Can you make it get faster as it rises? Yeah, sure we can. So right now it's moving really slow. So let's add to its velocity. Bubble velocity, and we're going to add to it. So in the math drawer and then back to the sprites drawer, we're adding to velocity y. Bubble velocity y plus, let's say 0.5 just to get started. Oh, that should be a minus. Math minus sprites velocity y bubble. Even the people who have done this for a while make mistakes. So run it, and there we go. That looks great. So just remember to subtract to go up on y. If you wanted to go down on y, you'd be adding to y. Reset run, there it goes. Let's finish and continue. And we're on slow down in reverse. So this looks like it's going to operate similar to the car we just did, keeping it on the beach. In this animation, a mouse runs past a cat. Let's change it so that the mouse slows down, stops before reaching the cat, then reverses direction like shown to the right. Take a look at the code that makes the mouse move. That's this velocity x minus 20. So this mouse is going to move fast. Oh yeah, he zooms across. Did you see him? All right. And we're going to add code to make the mouse change directions when it reaches the cat. So because it's got a negative value on x, we're going to add to x. So sprite velocity x, it's going to be mouse velocity x, adding mouse velocity x plus 1. Let's see what that looks like. Oh, that's great. Let's try 0.85 and see what that looks like. Reset run. Getting closer to that cat. I want to get even closer. 8.2. Reset run. Perfect. I like that. 0.82. We're getting that mouse even closer to the cat than in the animation up here. Let's finish and continue. And then we're doing the 5C floating balloon. Change the direction of the falling balloon to make it float away. All right. We could probably do that. We're just changing direction on Y. So it goes down through the bottom of the screen. Let's fix that with sprite velocity Y. Balloon, make sure you spell that correctly. I know that in my class, I have students that misspell balloon all the time. All right, let's see. And we're going to go here, grab sprite velocity Y again, balloon, and we're going to subtract, let's say 1, run. Oh, Nope, we're trying to recreate this. So we definitely want a value less than 1. Let's try 0.4. Still too big. 0.1 maybe. Ooh, it goes all the way to the ground. So let's try 0.15, reset run. There we go, that's perfect. Stops before it gets to the ground, just like in the sample. That's awesome. We'll finish there and continue. That's going to put us onto bubble 6. So we'll finish right here. And bubble 6 is our assessment bubble. So you want to make sure you do well on bubble 6. And on bubble 6, looks like gravity. Uh-oh, this rock is thrown in the air, but it never falls back down. Add code to make the rock slow down and then fall. Try different numbers. Okay, so it's going up, which would be subtracting from y. We want it to look like we've thrown it up and it's coming back down. So we're gonna add to y. So rock, math drawer, adding to y. And you can type this in just like you've seen in the past. I just tabbed over there. Let's do 0.5 just to see. We want to be stronger than that, right? So 0.2 maybe. That looks pretty good. Let's try 0.17. Get it closer to the top of the screen. I like that. I actually want to add to the rotation speed as well. 5. Cool. That looks really good. And I think that's it, right? Add code to make the rock slow down and then fall. Cool. Yep, we did it. Working on this complex sprite movement. All right, now let's do some of these. We are making good time, so let's jump in. We're working on A here, curve. All right, let's see. What do we need to do here? The plane is going up to avoid the first spike. Let's see. Yep. Oh, but it goes off screen. In the draw loop, update its velocity y so that it pulls down to avoid the second spike. So we want it to go up and down, and then maybe add code that moves the plane down. You may change the initial x and y velocity of the plane, but you don't have to. Okay. So let's see. Plane velocity y, right? So velocity y, plane to match the plane variable established on line 1. And we're going to add to that to make it go back down. And then plane velocity y again. And we're going to add to it. Let's try 1 and see what happens. Oh, 1's way too big of a number. Look at that. Crash. Okay. So let's try 0.5. Run that. And again, we're crashing. Let's try 0.3. Nope, not small enough. 0.2. Run. Ooh, just misses it. 0.2 works well. Oh, yeah. All right. We'll finish there and continue. And let's see. That's going to put us onto deceleration. Make the car slow to a halt before it goes past the top of the screen. So we're going to slow this thing to a complete stop. All right, so run, and it just zooms off. Let's see, car velocity y equals -15. That's what's making it go up really fast. Okay, add code to make the car slow down in the draw loop. Okay, we can do that. So velocity y, car to match the variable. And then we're going to be adding Let's see, adding to that velocity y. And let's try 0.5 to get started. Run. Okay, so he does stop before he gets to the top of the screen. Let's try 0.4 to get him closer. Ooh, right to the edge. All right, I like that. And then we need an if statement. Use a conditional to detect when the car's velocity is 0. So we're going to add a conditional. So go to your control drawer, grab the if statement. And then we're going to check if the car's velocity y is greater than 0. So greater than, if car's velocity y is greater than 0, then car's velocity y gets 0. Let's see, car gets 0. So run it. Perfect, beautiful, right before the edge. There's just barely a gap there that you can see. Maybe you can see it. I can see it. Let's finish there and continue. I think that puts us on C, jumping alien. All right, for the jumping alien, can you use the counter pattern with the velocity y to make the character appear to be jumping? Do this. Set the alien's velocity to make the alien jump when the spacebar is pressed. Right now he doesn't do anything, so let's make him jump. So velocity y, alien, is that his name? Yep. Alien velocity y, when, so I need a if statement, right? When spacebar is pressed. Yep. When key down space, then alien dot velocity y gets, let's say 2. Reset run. Oh, -2. There he goes. He's jumping. Let's speed that up a little bit. -5, reset run, space. There we go. Use a counter pattern with velocity to bring the alien down when it reaches the top of the screen. Okay, use the counter pattern with velocity to bring the alien down when it reaches the top of the screen. So control when it reaches the top. So let's look at that. All right, not quite getting to the top, but we'll see. So if less than sprite drawer, if sprite.x, if alien.x is less than, let's say less than 80, then we're going to add to velocity y. So where's math? Add. So alien velocity y is going to get alien velocity y plus, let's say 0.5 just to get started. Run it. Ooh. Is he ever going to come back down? Less than 80, right? And you're adding to velocity. Let's try a bigger number here. He's not coming back down. 3. What am I doing wrong here? Hang on, I will be back. So I caught what I did wrong. See this alien X? I am not the smartest man at the moment. So that's going to be alien.y, not alien.x. Change that back to a 1. Run. Let's see. Spacebar. There he goes. Okay. And then let's see, let's use the counter pattern, bring him back down, and then we'll set the alien's velocity and reset its starting Y location value to make it land on the ground. So we're going to set the alien's velocity and reset its starting Y location. So we're going to grab an if then else statement for this one. We need some math to make this Boolean expression, and we're going to say alien.y is greater than, so greater than operator, alien.y is greater than 300. He starts, oh, no. He starts at 310. So let's try 309 here, see what happens. Then sprites, so we're, oh, I don't need an else. Goodness gracious. It's not that complicated, right? Then sprite.y, alien.y is 310. We'll get it back to that starting position. And we're going to stop it. Let's see if that works without anything else. Okay. Hey, we're jumping, man. We're jumping. All right. Bonus challenge. Add a sprite that moves across the screen in a loop to give the alien something to jump over. Okay. So this, we're kind of creating a little bit of a game here. I like it. Very similar to the side scroller game, right? So do we have anything living here? No. Let's grab something to come across the screen for our alien to jump over. We'll grab a crocodile. We're going to flip him. Whoops. We're going to flip him. And then go back to the code. And let's get this crocodile in here. Crocodile. And let's start him off the screen. Let's start, well, whoops, Control Z. I don't even know how I did that. Start him off the screen down here, 380, let's do 350x. And we're going to start him off the screen, 450. And then probably need to set his scale because he's ginormous. We're going to set his scale to like 0.5. Set run. All right. So he's here. Let's bring him up a little bit. 325. There we go. And then we're going to make him move in a loop. So let's see. First, we need to give him a velocity. Oh, -4. Run it. There he goes. Okay. And then we're going to make him loop. So if croc.x is less than 0, then we're going to reset his location to 450 again. All right. Brilliant. Perfect speed, perfect jump. Beautiful. All right. There you go. Let's finish there, finish here. And is that everything? Who will win? Use what you've learned so far to race the cars and slow them down after they reach the finish line. All right, we can do it. Let's do it. And I think it gives you the option to choose any of those three, but we'll do this one. Use what you've learned so far to race the cars and slow them down after they reach the finish line. For example, use the race cars and finish line provided to program the cars to race to the finish line and then slow down once they reach it. Make your scene even more fun by setting the initial velocity of each car to random so that a different car might cross the finish line first each time. Ooh, okay. So on our animation tab, we've got a blue car, a purple car, an orange car, and a finish line. It looks like they're all set facing down, so I'll put the finish line down at the bottom of the screen. So let's do that first. We're just got a F line, finish line. We're going to put it down here at, let's say, Y200, Y325. I need the draw loop and draw sprites. Oh, I didn't set the animation. Okay, there it is. And then let's get our cars in here. Blue car. Blue car. Oh, won't you be a blue car? All right, and let's move him back up to the top center. So let's set him to maybe 30. There he is at the top. That worked out nicely. And then continuing here, I think there was a purple car and an orange car. All right. So purple car, going to be a purple car. And let's set its X to 100 and Y to 30. There we go. And then orange car. $330. Orange car. Orange car. Reset run. Perfect. All right. And then we're going to set their velocity Y. Okay. Blue car. Purple car. And orange car. And we're going to use the random number like it asks us to in the instructions to give them each a different speed every time the program is ran so that it's a different car that wins each time. So we're adding to Y. Yep. So between 1 and 10, reset run. Oh, we need to draw a background. All right, blue is the fastest that time, then orange, then blue again, purple wins, purple wins, purple wins, blue wins. Okay, I like it. So now, it wanted us to slow down when they reach the finish line. So let's see, sprites. We need an if statement. And we're asking if sprite.y is greater than If blue car dot y is greater than f line dot y, then we're going to slow down our car. Sprite velocity y, blue car dot velocity y gets, we're going to subtract blue car velocity y minus, or yeah, subtracts 0.8. Let's see, run it. That's too much. 0.2. And then he reverses, so we need another if statement maybe to stop him. Yep, so if, let's see, to make him stop. Is less than 0. Blue car velocity y is less than 0. And blue car velocity y is 0. Let's see. Nope. Maybe greater than 0. Let's show text and see. Oh, not version history. Show blocks again. Run it. Nope, that just pauses him. So it is going to be less than. Run it again. Oh, whoops. Less than, you silly head. Hit run. Show blocks. Maybe this is too fast still. Let's try it again. Nope. And this is going to take some work. There he goes. You can just see him. Reset run again. If he's going that fast, it doesn't work. Thinking here. Let's repeat this code for the other two cars. Control C, Control V, Control V. And then I'm going to grab purple car, Control C. And for this here, Control V, Control V, Control V, Control V, Control V. All right, and for the next one, it's going to be orange. So Control C, Control V, Control V, Control V, Control V, Control V. Let's run it. So the orange car won, blue car is very slow. So I'm going to change their range actually from like 3 to 6 maybe. See if that will make it work better. Yeah, there we go. So orange finished first. Purple, yep, Beautiful. Okay. Ooh, a tie. So purple won that time. Another tie. Yep. So I don't want to go bigger than 6. But I'm getting a lot of ties. So I might do 2 to 6. Give them another number to be potentially. Still lots of ties, but that's okay. It works. There we go. Finally, not a tie. Beautiful. So a range of 2 to 6 for velocity y at the beginning of the program. And then it's a matter of repeating code like this. If blue car.y is greater than finish line.y, then its velocity subtracts. And then if the blue car's velocity y is less than 0, then it gets 0 so that it doesn't reverse back up the screen. That works. Cool. So let's finish there. And then, if you chose racing spaceships or fastest animal, that's fine. I chose to do the who will win challenge. These are the same thing as the who will win challenge, just different animations or a different sprite set. That's it for me. I hope you had fun with this lesson. I know that I did. I can't wait for the next one, lesson 23. And we're going to work on collisions in lesson 23. And that's coming up soon.